Hello friends, in this session we are going to see the topic that is mixtures and alligation. This is nothing but the application of average, percentage and ratio like topics. So if your bases are clear, average, ratio and percentage, I call these three as the threshold, then definitely mixtures and alligation you are going to find it easy. And importance wise, yes, this is very important topic. You will find again no exam without the questions from mixtures and alligation, because as we can see, it has application of all three together. So that makes, of course, this as important. So important part to understand this topic is to understand what kind of questions come under mixtures, what kind of questions come under alligation. In fact, what is mixture and what is alligation? So we'll see that first. So consider this. If I take, say, 100 liter water, pure water. So this is a pure component. This is a pure component, pure water. It has only water into it. And if I take 50 liter pure milk, it is also again a pure component. And if I mix these two, now I am going to have 150 liter material, in which 100 liter is going to be water and 50 liter is going to be the milk. Now this material, which is the combination of pure water and pure milk, is called as the mixture. So mixture means combination of two or more than two pure components. So all the components in the mixture will have their own percentage or share. For example, in this 150 liter, water is 100. So if I ask you what is percentage of water, so percentage of water will be water upon total into 100. Basically, out of total, how much percent is the water is what percentage of water is. So water is 100, total is 150 into 100. So if you solve this, this is 2 by 3, means 66.66%. And then if I ask you what is the percentage of milk, it will mean milk upon total into 100. Out of total, how much percent is the milk? So milk is 50, total is 150 into 100. It is going to be 33.33%. If I ask you what is the ratio of water and milk, water is 100, milk is 50, the ratio is going to be 2:1. So in a mixture, you can have separate percentages of the components, you can have the ratio of the component, or you can have concentration of the components, concentration or fraction of the component. Now what mean by concentration or fraction? Concentration, of course, you can express in terms of percentage as well. The percentage of milk is 33.33%. You can say concentration of the mixture is 33.33%, because milk is the core component. Core component means water we use for dilution. So apart from water, whatever is there, alcohol, milk, acid, that we usually call the core component, and the percentage of core component can be considered concentration. But here, concentration can be expressed in fraction form as well. Means concentration of, if we talk about the mixture, means milk upon total. So if milk is 50 and total is 150, so we can say 1 by 3 is the concentration. Okay, so there are different ways to express the solution or the mixture. You can have the ratio of the components, you can have the separate percentage of the components, or you can have in terms of concentration. Got this? Now let's see what is alligation. So when you mix two mixture with their own component, you are going to have mixture of mixture. So when we talk about mixture of mixture, we basically solve the question regarding alligation based on that. For example, if I ask you the question, in 50% alcohol solution of 10 liter, how much water should be added to form 30% alcohol solution. So this is the question. So what we are doing is, in already established mixture, we are adding something else. Of course, water is a pure component, but we can add another mixture as well. That means when two mixtures are mixed to form a new mixture, those type of question come under the alligation. So first we can solve these type of question by normal method. As I say, if your basics are clear, you don't have to go in depth with every concept or every knowledge of the mixtures and alligation. You can solve with the existing knowledge as well. So what we can do is, you can just say we have 10 liter. In the 10 liter, 50% is the alcohol. 50% alcohol solution. Solution means mixture. So it will have 50% alcohol. So alcohol, if it has 50%, remaining, we can say it is a water. It doesn't matter what it is. We can say 50% will be water. So 50% of 10, that is 5 liter will be alcohol and 5 liter will be water. Into this, we are going to add some more water. So let's say we are going to add X liter water to this. So total mixture will now become, earlier it was 10. You are adding X liter water. So it will become 10 plus X. Out of which alcohol is still going to be 5 liter. Alcohol is not going to change. Alcohol will still be 5 liter. So out of this, the alcohol should be 30%. Because now we should have 30% alcohol solution. That means 10 plus X is 30% should be equal to 5. So we just have to solve for this. This is 6 times. So we have 60 plus 6x is equal to 100. 6x is equal to 40. X will be equal to 40 upon 6 or 20 upon 3 or 6.66 liter. So how much water we should be adding? We should add 6.66 liter water. So we can solve it like this, like general concept. But what we saw in our average session, that these type of question, they can consider as the alligation question. Here one portion is bringing its own percentage or concentration. Another mixture is bringing its own concentration. And if the resultant concentration is given, then we can solve for they are mixed in what ratio. So what you do is, we say first mixture has 50% alcohol into it, and second mixture, now second mixture has no alcohol. It is a pure water. But if we are on this side, we are writing the percentage of alcohol. So here also, in the second mixture also, we have to write the percentage of alcohol only. We can't say the 100% water is there. No. If 100% water is there, that means 0% alcohol is there. So we are using percentage of alcohol everywhere. So here also we write percentage of alcohol. Here also write percentage of alcohol. In the resultant also you will write percentage of alcohol. So in the resultant, the percentage of alcohol is 30. So that 30 you are going to write in the center like this. This is a mixture 1. And this is the mixture 2, which is of course pure water. That's why 0% alcohol. Then what we do is, we take their difference, which is 30. We take this difference, which is 20. And then we calculate the ratio. This ratio tells us in what ratio we should be mixing these two. This ratio tells us in what ratio we should be mixing mixture 1 and mixture 2. So mixture 1 is already 10 liter. Mixture 2 is X liter, that we are adding X liter water. The ratio here should be 3:2. So solving this, X will be 20 upon 3, which is 6.66 liter. So the water that you are adding, or mixture 2 in this case we are adding, should be 6.66 liter. So you can solve these type of questions using alligation as well. So what is the trait or what is the identity of the question to be solved by alligation is when the central number or the resultant percentage, resultant concentration is given, then you go for alligation. Because difference calculation then becomes easy. Because the central number is given, then you can calculate the difference easily, this side also, this side also. That means when you mix two different mixture, the resultant's concentration or percentage should be given. That is given, then go for alligation. So of course, different type of question when we solve, then only you can learn it better. So let's try solving some questions here based on alligation. Now let's see this. Now this is a very general basic question. In a 70 liter 70% milk solution, how much solution of 30% milk should be added so that to make a 50% milk solution? That means you are adding one mixture which has 70% milk, another mixture which has 30% milk, and resultant should have 50%. So on one side you write 70% concentration of the first mixture. On second side you write the 30% concentration of the second mixture. In the center you write the resultant, which is 50% concentration of the result. This is mixture 1. This is mixture 2. In this, we take the difference. This difference is 20. 50 minus 30 is 20. And then here we write this difference. 70 minus 50 is going to be 20 again. And then we calculate this ratio. And the ratio comes out to be 1:1. This ratio tells us in what ratio we should be mixing these two. So 1:1 means these two mixtures should be mixed equally. If this is 70 liter, this should also be 70 liter. So answer here is going to be option number 3. I hope you got this. Let's see one more. In two mixture, the ratio of alcohol and water is 2:7 and 5:4 respectively. In what ratio should these be mixed so that in final alcohol to water ratio is 4:5? So as I told you, you have to write the concentration when you use the alligation. Concentration of first, concentration of second, concentration of the result. Concentration means, as we discussed earlier, that alcohol is to water if the ratio is given 2:7. Concentration means alcohol upon total. It is not alcohol upon water. It has to be alcohol upon total. So if alcohol is 2 and water is 7, that means the total is 9. So alcohol upon total is 2/9. So here you will write the concentration of first mixture, mixture 1, mixture 2, and resultant. Everywhere you are going to write the concentration of alcohol, means alcohol upon total. So here if alcohol is 2 and total is 9, so 2/9 you will write. Here alcohol is 5, total is 9, so you'll write 5/9. And here the resultant is alcohol is to water 4:5. So alcohol is 4, total is 4 plus 5, 9. So you'll write 4/9. Now taking difference is easy, but still, if you find calculation into the in the fractions difficult, because sometimes it might happen the different denominators are there. Here 9, here 7, here 5. Then the definite calculation is going to be difficult, calculation of fractions. So what we do is we multiply everywhere with the all available denominators or their common multiples. So if 9, 9, 9 is here, so you everywhere multiply with 9. If there was 5, 7, and 9, then you multiply everywhere with 5, 7, 9. All three places you have to multiply 5, 7, 9, 5, 7, 9, 5, 7, 9. That means basically you multiply with the common multiple of all the denominators. Here everywhere is 9, so you multiply only with 1 9. But everywhere, all three places. So what happens is 9 9 gets cancelled, 9 9 gets cancelled, 9 9 gets cancelled, and what remains is 2, 5, and in center there is a 4. And then it becomes very easy to take the difference. This difference is 2, this difference is 1, and that tells you in what ratio these two mixtures should be mixed. The answer is 1:2. You should be mixing these two mixtures in the ratio 1:2. I hope you got this. Let's see one more. A jar contains mixture of two liquids A and B in the ratio 4:1. When 10 liter of the mixture was taken out, 10 liter of liquid B was poured into the jar. The ratio becomes 2:3. The quantity of liquid A obtained in the jar initially was. So first of all, you need to understand a concept about mixture. That is, if you take out some part of existing mixture, the concentration or the ratio doesn't change as long as you are just separating. For example, if I say we have 100 liter milk solution. Milk solution means there is some milk, some water. So let's say there is 90 liter milk and 10 liter water in. This much is milk, this much is water. What is the ratio between milk and water? The ratio is going to be 9:1 between milk and water. If you say take out 10 liter out of this, so that 10 liter will also have the ratio between milk and water 9:1. Ratio doesn't change. See, mixture is homogeneous. Homogeneous means it is thoroughly mixed. So whatever amount you are taking of it, every bit will have milk and water in the ratio 9:1. That's what homogeneity means. Properly mixed. Every drop of it will have the same ratio between milk and water, that is 9:1. Is called homogeneous. This 10 liter will also have milk and water in the ratio 9:1, means 9 liter milk and 1 liter water. And what remains now is 90 liter. That 90 liter will also have milk and water in the ratio 9:1. So that means 81 and 9. 81 liter milk and 9 liter water. So this is very, very important concept one must understand. From existing mixture of certain concentration or ratio of the components. So like here, milk and water have the ratio 9:1 between them, or milk is 90% into this. Milk is 90%, concentration is 90%. If you take out some portion that will have the same composition or same concentration, so milk will have 9 parts and water will have 1 part, or percentage of milk will be 90% still here. And what remains will also have the same ratio, same composition, same concentration. That means 90% milk and 10% water. 9 parts milk, 1 part water. Okay, again I'm repeating in simple words, from existing solution, or if you separate the solution, if you only separate, don't add anything into it, just separate an existing solution. So by separating, the concentration does not change. Whatever the ratio initially between the components were, will be the ratio in the separated part as well. Both the separated parts, this 10 liters and these 90 liters, will also have the same ratio. That is what very important teaching here, because in this type of question, this is a very, very, very common type in all these banking exams. This type of question I called a single time replacement. So what happens in this question is, from existing mixture, you take out something, and now in the remaining part, you put something. So only one time you are doing this action. You take out something and you put something. This is called as one-time replacement. One-time replacement is very, very common in the banking exams because they are the toughest one. Multiple replacement questions are very easy. If you do 2-3 times the same process, that is easy because we have direct formula for that. These type of questions you have to solve by analyzing. You can't just use direct formula all the time. And analyzing is easy. Once you understood what we discussed earlier about that separation of mixture, then this becomes very easy. All you need to understand that in a jar, it had 2 liquids A and B in the ratio 4:1. If you take out something, now what problem student faces, they start upfront considering that if A is 4x and B, then it will be x, because the ratio is 4:1. And now when you took 10 liter out of it, and then it becomes really confusing, because how much from 4x goes and how much from x goes, because we don't know what 4x and x is, and out of which you are taking absolute figure, which is 10 liter, then it becomes really, really messy to further proceed this. That is what students find difficult about this. So that is why I told you that understand that simple concept, that even after taking out that 10 liter, whatever remaining will also have the same ratio. So you don't have to start your question upfront from here. Let the 10 liter go. Now, whatever remaining will also have A and B in the ratio 4:1, because we just saw as long as you are separating the mixture, ratio does not change. So if the ratio initially was 4:1, ratio in the remaining mixture will also be 4:1. So now you can say if A is 4x, B will be x, and together they are going to be 5x, because this is 4x, this is x. And now what we are doing is, liquid B, 10 liter of liquid B was poured. So you are adding now 10 liter of B. A will still be 4x, but B now is going to become x plus 10. Such that the ratio between A and B now becomes 2/3. This new ratio between A and B is 2 upon 3. Just solve here. This is 12 and 2. So 10x is equal to 20. X will be equal to 2. Or you can solve back cancelling out upfront 2 as well, like this 2 times. So 6x is equal to x plus 10. 5x is equal to 10. X is equal to 2. If x is 2, that means this 5x was 10 liter. What is 5x or what is 10 liter? 10 liter is the remaining solution. After taking out 10 liter, the remaining solution is 10 liter. That means initially it was this 10 plus the 10 you took out, that is 20 liter. Initial solution was 20 liter, in which the ratio between A and B was 4:1. So how much was A and how much was B? Easily 16 and 4. A would be 16 liter. I hope you got this. So this is, as I said, is called the one-time replacement question. Very, very, very predominant in the exams like SBIPO, RBI Grade B. A good exam basically. So that's why they are never going to ask you the typical questions now, because they know student directly go for that allegation without even understanding what the allegation is. They just see 10%, 20% and 15%. They write it, and so that's why they stopped asking those questions. The questions are going to be single replacement based. So just follow this process and you'll still get the answer every time conveniently. Let's see one more. Now this is again a similar type of question, very, very famous question. This question I have seen in 3 different exams with the same figures, and good exams like CAT exam, like SBIPO exam, RBI Grade B exam. So this is actually important question. Can contains a mixture of 2 liquids A and B in the ratio 7:5. When 9 liters of the mixture is drawn off and the can is filled with B, the ratio of A and B becomes 7:9. How much liters of liquid A was contained by the can initially? So first of all, you can answer this in 1 second, because A and B are in the ratio 7:5. So ratio topic tells us that A has to be multiple of 7, B has to be multiple of 5. This is how the ratio works, at least in competitive exams. This is how the ratio works. So A has to be multiple of 7 and there is only one multiple of 7, that is 21. First of all, 21 has to be the answer. But because, as I said, this is actually very important question. And again, it is a single replacement question. Again, let me explain how it is a single replacement question. We have an existing mixture between A and B, where A and B in the ratio 7:5. You are taking out 9 liters from it. And in the remaining, you fill with B, and that means the 9 liter you took out, you are filled with B, means again you put back 9 liters of B. So single replacement you are doing. So again, you can start your question with the remaining solution. We had a solution initially which had A and B in the ratio 7:5. From this existing mixture, you took out 9 liters. So we start our question. After that, remaining will have the ratio between A and B as 7:5. Ratio does not change as long as you are just separating. So you took out 9, ratio will still be 7:5. So if A is 7x, B will be 5x, and together they are going to be 7x plus 5x, that is 12x. So we now have 12x liter remaining solution, in which A and B in the ratio 7:5 means 7x and 5x. Into this, you pour B 9 liter, because you took out 9 liter earlier, you pour 9 liter of B again. So A will still be 7x, but B now is going to become 5x plus 9. 5x plus 9. And the ratio between A and B is going to become 7/5. So just solve this. 7 gets cancelled. Sorry, 7/9. New ratio is 7/9. A upon B, new ratio is 7:9. 7 gets cancelled like this. 9x is equal to 5x plus 4. 5x plus 9. So 4x is equal to 9. X is equal to 9/4. So just put x is equal to 9/4 here. 12 into 9/4, that is 27 liters. 27 liters is the remaining mixture. After you took out the 9 liter here, what remains is the 27 liter. That means initially it was this 27 plus this 9. It was 36 liter initially, in which A and B were in the ratio 7:5. So how much was A? How much was B? I hope everybody can break a number into the ratio, given ratio. If not, please watch our ratio video. So 7 plus 5 is 12, and it is 12 3 times. This also gets 3 times, means 21. This also gets 3 times, means 15. That means in the initial solution, A was 21 liter. Exactly the same type of questions that we have seen previously, the previous question, right? So as I told you, these the questions are there in the market these days. Everybody should know how to tackle the single replacement question, because lesser than this, only allegation based question, they have become obsolete. They have become so easy that any student, any candidate solve this. One step above this, multiple replacement, those can also be solved. Those questions can become actually very tricky if they want to make it. Otherwise, if they want to ask a simple question, then it becomes very easy question. But this is the type which actually needs some thinking, and that is why these are there in the market these days. So you should do some practice and get yourself ready for these questions. Let's see one more. Now SBIPO, again same type of question. Mixture has milk and water in the ratio 4:1. Then 50% of the mixture is taken out and replaced by 24 liters of water. So again same thing. You took out some mixture and you replaced it by water. One-time replacement. You start your question with the remaining mixture. So remaining mixture also has the same ratio that original mixture had. So from original mixture, you took out 50%. What remaining will have milk and water in the ratio 4:1. That means if 4x is the milk, x will be the water. Together it will be 5x liter solution. So now we have 5x liter solution in which milk and water are in the ratio 4:1, 4x and x. Now you replaced it with 24. That means you're now going to add, because this is the remaining. You took out 50%. So this is the remaining 5x. Into that, we are adding 24 liter water. 24 liter water will get added. So milk will still be 4x, but water will now become x plus 24, such that the new ratio between milk and water is 1:1. Now 1:1 ratio means both are equal. 1:1 ratio means both are equal. So you can directly equate this. 3x will be 24, x will be 8. If x is 8, that means the remaining solution is 40 liters. This remaining is 40 liter when you took out 50%. That means when you took half, what remained half is for 40%, 40 liter. That means that initially it was 80 liters. Initially it was 80 liters, out of which you took out 50% and remained was 40. Easy? Let's see one more. Ratio of milk and water is 5:4. If 2 liters of water is added, ratio becomes 10:9. Find the new amount of water in the mixture. So, you know, if the new ratio between milk and water is 10:9, that means new amount of water has to be multiple of 9. And in the ratio, as you can see, there is only one multiple of 9. That has to be the answer. But let's solve by proper process. It is a very easy question. This time there is not even replacement. You are just adding something. So you can directly start your question considering milk and water in the ratio 5:4. Means if milk is 5x, water will be 4x. Into this, you are adding 2 liters of water. Milk will be 5x, water will be 4x plus 2. And the ratio between these two is 10:9. Milk is to water is 10:9. Just equate this ratio. 5x upon 4x plus 2 should be 10/9. This is 2 times of 5. So 9x and 8x, x will be equal to 4. Just solve this, x will be equal to 4. If x is 4, the new amount of water will be 4 into 4, 16 plus 2, that is 18. New amount of water will be 18 liters. I hope you found this easy. Let's see one more. Again, single replacement type of question. In a vessel, there are 2 liquids, A and B, in the ratio 5:9. 28 liter mixture is taken out and 2 liters of liquid B is poured. So we had some solution which had A into B in the ratio 5:9. Out of this, you took out 28 liters. What remaining will have the same ratio? So, you know, we start our question with the remaining solution. Remaining will have A and B in the ratio 5:9. That means if A is 5x, B will be 9x, and together they will be 14x. So we have a remaining solution 14x in which A and B are in the ratio 5:9, hence 5x A, 9x B. Into this we are pouring 2 liter B. So A still is 5x, but B now becomes earlier 9x plus 2. This ratio between A and B said 1/2. Thus the ratio is 1:2. Just solve this. 10x, 9x, x will be equal to 2. If x is equal to 2, that means the remaining solution is 28 liters. 28 liters is remaining when you took out 28 already. That means initially it was this 28 plus the 28 you took out. Initially it was 56 liter. And that is what it asked. Find the initial quantity of the mixture in the vessel. So total mixture in the vessel was 56 liter. Easy. Let's see one more. Now this is a different type, but yet easy, very, very easy. Alloy of copper and aluminum has 40% copper. So copper and aluminum, if it has 40% copper, that means 60% aluminum. So what is the ratio? Ratio is going to be 2:3. Another alloy of copper and zinc, it has copper and zinc in the ratio 2:7. These two alloy, this alloy and this alloy, we are going to mix in the ratio 5:3. So how much amount to be take, it is in our hand. You just have to maintain that we are taking these two alloys in the ratio 5:3. You just have to maintain this ratio. That means if you take 5 kg of first, you'll have to take 3 kg of second. If you take 10 kg here, you will have to take 6 kg here. You just have to maintain this ratio and you can take the kgs of your own choice. So we should take kgs or the alloys such a way that you can easily break this in the ratio 2:3 and second part into the ratio 2:7. So what is the number that you can easily break in the ratio 2:3? That should be the number which is multiple of 5, because 2 plus 3 is 5. 2 parts here, 3 parts here. So total 5 parts if there are there, then it becomes easy to break them in the ratio 2:3. That means the total number should be multiple of 5. And here, so if you take 5 kg here, because 5 is the multiple of 5, so we'll have to take 3 kg here. But can we break 3 in the ratio 2:7? No, because 2 plus 7 is 9. So you would want multiple of 9 here instead of 3. So if you want multiple of 9, so you will take 9, multiply it here with 3. So you have to multiply here also with 3 to maintain the ratio. That means if you take the first alloy 15 kg, second alloy if you take 9 kg, then what we are doing is we are maintaining this ratio 5:3. Also, we are taking the numbers which we can easily break in the said ratio. So if you take the alloy 1, 15 kg, breaking it into 2:3 is very easy now. 2:3, 15 kg means 6 and 9. So 6 kg copper, 9 kg aluminum. And breaking 9 kg in the ratio 2:3 is again very easy. 2 kg copper, 7 kg zinc. Now the total copper if you collect 6 plus 2, the total copper is going to be 8 kg and total aluminum is going to be 9 kg. They are asking quantity of aluminum is what percent more than the copper is what percent more than the aluminum is what percent more than the copper. So aluminum is 9, copper is 8. It is 1 more as compared to 8, and the fraction value of 1/8 is 12.5%. So it is 12.5% more. I hope you got this. Let's see one more. A milkman buys milk at 25 per liter and adds 1/4 of the water to it and sells the mixture at 26 per liter. His gain percentage. Basically, this is the question more of a profit and loss, but yet we can solve it by normal concept. See, 25 rupees per liter he has, and he adds 1/4 of the water. So if you say he has 4 liter pure milk, so what is going to be the cost price for him? 25 of 5 liter per liter. So 25 liter per liter and 4 liter means 100 rupees is the cost price for the shopkeeper. He adds 1/4 of the water to it. 1/4 of the water. 1/4 of the 4 means 1 liter water to it. 1/4 of the 4 is 1. 1 liter he adds water, and now 5 liter mixture he has. The complete mixture he sells at 26 rupees. So selling price is going to be 26 rupees per liter, and he sells 5 liter. 26 into 5, 130 rupees. So he bought the stuff for 100 rupees and he sells it for 130 rupees. So there is 30 rupees profit on 100, or 30% profit. Percent profit means the profit is what percent of the cost price. So there is clearly 30% profit. Easy. A mixture contains 80% acid and rest water. Part of the mixture that should be removed and replaced by the same amount of water to make the ratio of acid to water is 4:2. So you know, whatever the mixture initially was, when you remove something, replace means you remove something, the remaining will also have acid 80% and rest water. So again, we can start our question with remaining. So remaining will have acid and water, 80% acid, 20% water. That means you can say ratio is 4:1. So you can directly say it. In this question, it doesn't even matter you take X or not, because they are asking portion, what portion you are in. So you say the remaining is 5 liter. In that 5 liter, alcohol is going to be 4 liter and water is going to be 1 liter, because the ratio is 4:1. And now you add same amount of water, whatever you removed in initial, whatever initial acid and water was, the total was, you removed, let's say, X liter from it. You are adding X liter of water into it. So acid will still be 4 liter, but the water is now going to be 1 plus X liter. The ratio between acid and water is said 4/3 now. So just equate this. 4 gets cancelled. 3 will be equal to 1 plus X. That makes X is equal to 2. That means what you removed was 2 liter. That means initially it was this 5 plus this 2, 7 liter. So out of the initial 7 liter, you removed 2 liter and you added 2 liter water. That means you replaced 2/7 of the total mixture. Out of 7 parts, you took out 2 parts, or you replaced 2 parts. That means 2/7 is the fraction. I hope you got this. "49 kg of blended tea contains Assam and Darjeeling tea in the ratio 5:2. So 49 kg, it has Assam and Darjeeling tea in the ratio 5:2. It is very easy to break this number into 5:2, because 5 plus 2 is 7. And this is 7 times of it. This also becomes 7 times. This also becomes 7 times. That means it has 35 kg Assam tea, 14 kg Darjeeling tea. Into this, you add some portion of Darjeeling tea, because it says the quantity of Darjeeling tea is to be added. So now Assam will still be 35, but Darjeeling will now become 14 plus X. The new ratio of Assam and Darjeeling tea is said 2/1. So let's solve here. By cross multiplication, 35 is equal to 28 plus 2X, or X will be equal to 3.5. So what amount of Darjeeling tea you should be adding is 3.5 kg. I hope you got this. So there are these different type of questions that can appear in your exam. Also, of course, we'll have some more variety of the questions in our upcoming practice session. We'll have a combined practice session for ratio, alligation, average and mixtures alligation type of question. But meanwhile, you can solve different questions and connect us for any difficulties. Okay, then bye-bye. Have a good day.